The length of the rectangle is 12 units long, and the width is 9 units. Great work if you found these two numbers. The key to this problem is that the diagonal is 15 inches long. The diagonal of a rectangle cuts from one corner to an opposite corner. So we can draw in this line and consider this to be one of the diagonals. This line would be the other diagonal, but we only need one triangle in order to figure out the side lengths of our rectangle. We know the diagonal is 15 inches long, so we can label this with 15. We'll let the width of the rectangle be x, since we know the length is 3 inches longer than the width. This means that the length must be x plus 3. Here again is another case where we're using algebra to relate two things. We have one unknown, which is the width, and we're relating it to the length, since the length is 3 inches longer than the width. Now we have a right triangle, and we're ready to use the Pythagorean theorem to solve for x. We'll square each of the legs, which is this side, and we know if we sum those squares together, we'll get the square of the hypotenuse, or 15 squared. We'll combine these like terms together to get 2x squared plus 6x plus 9 equals 225. Next, we'll subtract 225 from both sides, so we'll have this quadratic expression set equal to 0. These terms are all even, so we can divide our equation through by 2. This gives us x squared plus 3x minus 108 equals 0. We find factors of negative 108 that sum to positive 3. Those factors are negative 9 and positive 12. So we can write these two factors and then set each one equal to 0 to solve for x. So x can equal positive 9 or x can equal negative 12. A negative side length wouldn't make sense in this case, so we'll let x equal 9 here. So if the width is 9, then we know that the length must be 3 more than the width, or this would be 12 units. Again, great algebra thinking if you got these two numbers.